Hi, my name is Haim and I will deliver the session about using types in Python, using type ints, adding annotations that provide more information about the expected types when we call a method or when we call a method and a value is returned back to us, and so on. Well, based on my experience, I believe that most developers don't add type annotations to their code. And actually, by not adding those type annotations, the quality of their code is damaged. We can add type annotations to our code in order to specify the expected data types for variables, function arguments, and the returned values when calling specific functions. We can use the typing module. There are other modules that can assist us, and we can, bottom line, include basic types in our code like int, str, float, complex types, and specify exact information about the type of every element, such as list, dict, tuple, and we can even use union and generics. So, why is it so important to add types to our code? Why can't we just ignore the types of the values we work with? Well, it seems that by adding types, annotations that provide information about the type of a value, the expected type when calling a function, the type of the returned value, it seems that by adding those annotations, the quality of our code improves. We have less bugs, and when we have bugs, it is simpler to track them, thanks to the fact that we have annotations that provide information about the types. In addition, having annotations that provide information about the types improve the collaboration between the team members. This isn't new. The same problem we have with Python that allow us to code without specifying types exists in JavaScript. In JavaScript, the solution is usually to use another programming language called TypeScript, and then that code we wrote in TypeScript is compiled into JavaScript. During the development phase, we use TypeScript, and when we violate, for instance, calling a function that expects getting a number and we pass over a string, then we get an error, a compilation error during the development phase. JavaScript is still the programming language that is executed. TypeScript helps us during the development phase. Similarly to TypeScript that help us during the development phase and eventually the code that is executed is code in JavaScript, something similar can happen with Python. We can add annotations that provide information about the types being used to our code in Python. Those annotations mean nothing. They have nothing with the execution of the code itself. If the code itself violates those annotations, it will still execute successfully. However, during the development phase, we can identify those violations, those cases in which one developer called a method that was developed by another developer, and that other developer developed a method that expects getting a number, and the first developer, instead of passing over a number, pass over a string, for instance. In such case, the code will still execute, but during the development phase, we can identify that violation. So the bottom line, adding type annotation to our code can be highly useful, especially when dealing with large-scale projects. Now, the traditional way, just code in Python, forget about the types, everything will be okay. Well, everything is dynamic, flexible, fun, and so on. Indeed, is very popular. But if you check what happens in the industry, then you find that Python is being used more and more in large-scale projects. When dealing with a large-scale project, we can't ignore the types. We cannot assume that everything will be okay. The risk that someone will define a function in a large-scale project, a function that expects getting a number, and another developer will call that function and pass over something that is not a number, a string for instance, that risk exists. Only by adding annotations that provide information about the types, and then by using static analysis tools that verify that the entire project is coded properly according to the annotations that provide information about the types, only by doing this additional step, we can ensure that during runtime, we won't get cases in which a function is invoked and a value is passed over, but its type is not the expected one. So, what can we do in Python? Well, using annotations that provide information about the types in Python, actually it is a huge topic. There are lots of possibilities. We are going to taste some of those possibilities, just some. In my opinion, this can be the start. So, when dealing with the basic types, it is very simple. Int, float, str, bool, and so on. We can easily specify to the right of the variable, as in this case. Or if we are defining a function and we want to specify the type of the returned value, then arrow and the type. So in this case, for instance, you see a definition of 3 functions. Each one of these 3 functions expect getting 2 values. Each one of them is of the type int. Each one of these 3 functions return a value that its type is int. So this is an example for basics, annotations that provide information about typing, the very basic ones. Let's move forward. Let's explore the possibilities when dealing with complex data structure, such as list, set, and so on. So in this case, we can use the typing module. And as you can see in this code sample, here we have a definition for the function process logs. Now, process logs has one parameter. Its type is list, and then you can see in square brackets str. That means that when calling process logs, the function expects getting a reference for a list object that holds strings. Now about the returned value is a reference for a dict object that its keys are of the type string, and its values, each value that is attached to a specific key, each value is a list of strings. The typing module even provides us with support for using generics. If you are familiar with generics in C#, Java, TypeScript, you can find something similar in Python. Take a look at this code sample. Over here, we have a definition for the function getFirstElement. Now, getFirstElement has one parameter. Its type is list. Now, the T letter it represents a specific type. Specific type we don't know for now what exactly that type will be. However, if you see it, if you look at line 3, you can see that T is assigned with the value we get when instantiating type var and passing over the letter T. That means that whenever you see T in the definition for getFirstElement, then you can imagine that it is a specific type that we don't know what is that type when we define the function, but we know that when the function will be executed, will be invoked, then the type of those elements, the list alt, that would also be the type of the returned value. As you can see in line 5, we have at the end of the function title, we have a arrow and the letter T means that the type of the return value when calling this function is T, the unknown type. The unknown type that all we know about it is that it is going to be the type of every element in the list. That list that we will pass over its reference to this function. And that type will also be the type of the returned value. We can even use the type statement for creating aliases for specific types. For instance, let's say that we want to create an alias for a list of floats. So we just need to type the keyword type, then we choose the alias we want. Let's assume that we want vector, and then equal, you can see that in line 1, list square brackets float. That means that wherever we specify vector, it means that we specify list plus the square brackets and float inside. So now if you look at the function scale, you can see that it has two parameters. Factor, its type is float, and data, its type is vector. Now, vector is actually a list of floats. The returned value of the function scale is also of the type vector. So now the entire code makes sense. We can even create new types. There is a class, new type, we can use. And over here, for instance, you can imagine that we created a new type that its name is user ID. The variable user ID is assigned with that new type. And then at line 5, we can just write user ID, and that will be enough for everyone to understand that the type of the parameter user ID of the function getUsername, the type is user ID. And as you can see in line 3, every user ID object actually wraps a value of the type int. The returned value of getUsername will be of the type str. So at line 7, you can see we can call getUsername. We pass over a reference for a user ID object that wraps the value 1, 2, 3. The returned value will be assigned to user A. The returned value will be of the type str. User A, at line 7, its type is str. Python even supports union types using the small operator. As you can see in this case, we have the definition for the function calculate, and calculate as one parameter. Its name is number, and the type of number is either int or float. That means that when you call calculate, you must pass over either a value of the type int or a value of the type float. The same with the return value. It must be either of the type int or of the type float. Now, at line 4, you can see that we have a variable. Its name is temp. Its type is float. And that's fine. We call calculate. We pass over 3.0, which is float. So this is fine. And the return value is also of the type float. Now, let's assume that we added to our code annotations that provide information about the types. What is the next step? After all, those annotations mean nothing when the code is executed. If the code includes violations of those annotations, we won't get any error when executing the code. What we can do is using a static analysis tool. A static analysis tool that will verify that the type annotations in our code are taken into consideration in every line of the code, so that if we have a function that expects getting int and there is a line where that function is invoked and the value that is passed over is not int, we will get an error message when using that static analysis tool. A static analysis tool is a program that goes over the code without executing it. We can use the static analysis tool as part of the development cycle before we move forward and execute the code, before we move forward and deploy the project on the server, for instance. There are various static analysis tools you can use. I recommend you to start with MyPy. It's fairly simple. So let's summarize. We saw that we can add types annotations. We understand that we can significantly improve the quality of our code, the quality of our project by adding those types annotations. And we understand that we need a static analysis tool to verify that the entire code respects those annotations that provide information about the types. So if you have any questions, I will be very glad to provide you with answers, and I wish you to enjoy the rest of the conference.